City, welcome everybody to my session. The session I'm dealing with is analyzing SQL Server wait stats. Discover when SQL Server is waiting. First question of all, who was in my first session in the morning? A few of you, okay? So this will a very short introduction to the wait stats, and then I have some demos for you where I resolved some issues with customers with SQL Server Monitor. Come on, oh gosh, I'm so nervous, you see. I've forgotten this clicky. So, okay, this is me. The most important thing for you to know is my email address. The rest is forget about. The email address is the real address. That means if you have some questions concerning this session, please write me an email. I promise to answer every email. The only thing I won't answer is give me your PIN number of your credit card or anything else, but everything concerning my session I will definitely answer. What can I not promise is I can't answer it maybe at the same day, but I promise I will. This is some commercials from me. Master, MVP, done, finished. Okay, so this is the agenda. What is a wait, what is a queue, when SQL Server waits, and then we have some common wait stats, what I will show in a demo. This we dropped, this is okay. When SQL Server waits, think about the following. SQL Server is running a thread, a process on a CPU. The thread which comes into SQL Server can have three different statuses. The first status it can have is the so-called running status. Think about a supermarket. When you're in a supermarket and you're at the cash and you lay your food on the band, then you're in a running mode. You're in a slightly good mood when you pay and you're queuing. So, but it might be that when you go through the supermarket and then you have to wait, for example, in a queue for the cheese. There is a lady cutting the cheese, and in that moment you have to wait. That means that you will move from the running mode into the suspended mode. And the suspended mode does always mean you are waiting for any resource, whatever it is. So anytime when you're in the suspended mode, you have to wait. When you've got your resources, let's say, so the cheese is ready, everything is packed, you can go ahead, then the next thing you have to do is, and this is pretty cool, you can't do it like in real life, you can't go directly to the cache, no. You have to queue. That means that you're in the row and you are waiting to get back to the cache machine, whatever it is. So there might be a problem if you're waiting too long. But first of all, first attention to this spit number 60, which is my thread, which is in a running mode. So he's at the cache, and beep, beep, like he has done. And here you can see the number 68, which is waiting for a resource, which is lock, a modification for shared lock. And this is waiting, and you can see here the number 55, which is directly behind the 60. Hurry up. So what will happen? When the 60 is ready, the 55 will move up to the running mode, and now it's on the row, and it can be handled. So you can see that the 68 now has gotten his resource, and what will happen, it will move automatically into the runnable mode. This is a fantastic issue, and a very simple issue, isn't it? So what will happen now is the following. I think that everybody, if you have seen in the supermarket, you were there with a little ice cream, and then a family with such a huge amount of food are standing in front of you. And you are waiting there. It's summer, it's 35 degrees, and you want to pay for your ice but you can't. So SQL Server does handle it in a very fashion way. SQL Server is dealing with that with saying, okay, as much things you have in your basket, at least you have to finish everything in 4 milliseconds. This 4 milliseconds is called the quantum. And this is fixed, this is hard-coded in SQL Server, and you can't change it. That's pretty cool. So what does this mean? If the 55 is running out of this 4 milliseconds, it has to move directly back to the runnable queue. And this is very cool. So if you're in a supermarket and you see someone with a huge basket and you say, back to the runnable queue, that's really cool. And you see that now the 59 is in the running mode, and the 55 now is the last one. I think it's very cool, isn't it? So this is how SQL Server is dealing with threads when they are concurrent. And this makes it so easy, let's say, to define where SQL Server waiting. We have only these three aspects on one CPU. This circle here, what you see here, is for every single CPU the same. So now we come to the product. You know, it's commercial. It's Redgate SQL Monitor we are dealing with. And I'm a consultant for since 1991 and working with SQL Server since 1998. And I have very much customers where I try to convince, let's say, that they are doing something wrong. And this is where SQL Monitor did help me, not only for detecting a problem in the system, but for convincing people that they are doing some mistakes. And when you are working with a SQL Monitor, what I feel very good, but very cool, is that you have a very cool first view of everything. You see that the databases are online and everything is okay. And here you have the general information. And concerning the wait stat, and that's what we're dealing with, you have a very cool list of the wait stats which have occurred within the last whatever period you define. And this gives me the opportunity, for example, for the first example I give you, that I can show the customer what they've made wrong, for example, in their database design. Demo. I think a presentation without a demo is not a presentation, it's boring. And it gives me a little bit more time to breathe. So the first thing what I want to show you is how SQL Server, how I have convinced a customer with the wrong design they have. First of all, before I start, and maybe there will be some at the end, what do you think? What is the best for database design? A cluster key with an identity integer, with a GUID, or a heap? Who think that a clustered index in a high concurrent system is the best you can have on a table? Ooh. Who would say it's a GUID? Yeah, cool. And would say it's a heap? Hey, come on, hey. Nobody is for nothing. That's cool. That's like in Germany, huh? Yeah. I'll go. Okay. So I will. We're dealing permanently with tables with contiguous growing integer values. 1, 2, 3, 4, 5. It is a web application. And when I saw it the first time, I said to him, hey, this is the wrong design what you're doing. I would recommend to use GUIDs or a heap. And he said, no, I read that. It's from Adam Mechanic, from Paul Rendell. Everybody is telling me, use this one. And then what I did, I demonstrated him with a very simple example, what I will show you here, that it's not always true because it depends on the workloads you have. The system what I have here is a very simple one. So everybody can read this here, yeah? I create a demo database. Come on. And before I do that, have a look. Oh, stop. There is a little mistake. You need some explanation for the different disk drives. The drive S is it's not an SSD. It's a normal hard drive. The drive F is my SSD. And what I wanted to show to the customer is two things. First of all, that his assumption that a contiguous running integer on a cluster key is a wrong way. And the second one I wanted to show is that he has a wrong design based on the location of the log file. So, set to simple. I go to the DemoDB, and what you can see here, I have three different tables. I have a table called numeric table, the GUID table, which has exactly the same size. This is important, otherwise I would cheat. Yeah, so it's 388 bytes char, so that every record has the same length, and I have a heap. And what I'm doing is I'm creating a procedure which is only for the workload, and it's a very simple thing. What it's doing, it's inserting 1,000 records into the table depending on what parameter I give. Is it a numeric table, is it a GUID, or is it a heap? So this is my procedure. Now let's see what happens. Who does not know what O-Stress is? I asked it the first time when I had my session here. O-Stress is a tool from Microsoft which you can use to simulate workloads with multiple accounts. So it's a really great thing. I like this. And I sometimes wish that people would quite often use this to see how the workloads are changing as more connections you have. So it's Microsoft Corp, it's RML utils, and the RML utils are for free. That means you don't have to pay for it. It's for free from Microsoft, and you can use it. So what I'm using, O-Stress minus E, that means I go with an integrated security into my server. My server is Lenovo 1 SQL 2012, and I would like to run a query called exec. Copy paste is my friend. Come on, whoop. So. And I run it first with the numeric account, okay? So, and I run it with 100 currently, so 100 connections at the same time on my demo DB in a quiet mode. So I don't want to have an output. So this is the table with the clustered index on the integer. So let's see, we run it. It takes a little time. In the meantime, I can talk to Simon and say something about me before I start singing. And believe me, I think that you really want to see me talking with Simon instead of singing. That won't work. So I think that in approximately 20 seconds, it's finished. So that means that we have 100 concurrent connections running and hitting on one dedicated table. 15 seconds, wow. Yeah, because the CPU is cold. This is okay. So I run it again with the GUID. What do you think? Faster? It must be. Yeah. So 6 seconds. Oops. Very interesting. So if you're dealing with a web shop, it might be very cool to rethink the design of your system. And now comes the heap. So, and the heap will fill up the heap table where there is no structure in. That means it might be that it's quite fast, but from my experience, it's nearby the GUID. Oops. This is not normal. This is because it's live. Yeah? So normally it must be around 6 seconds too. So that is my experience. So where comes SQL Monitor in the game? Well, what I am doing was I have shown my customer what the difference is concerning the page splits, for example. The page split is a very, very expensive transaction, which means if you have a clustered index and you fill in data within 2 rows in a clustered index, then the page has to be split because it needs to be guaranteed that the values are ordered. So, and what SQL Server in this case will do, it uses the page, put the half of the page at the very, very end of the index, and then put in this one record you want to insert. And that is a very cost incentive part. It's cost you per page split approximately 3 times more as a normal insert process. It depends on the size of the rows. So, and what I do now is, and this is a fantastic thing, that I can look into the analysis and looking for the page splits. Here they are. So, put them in and you see, oh, very high. Just a second, I have to put in the, come on, here we go. 2,500 and let's see, page splits per batch. Oops, stop. So, I add this one. And I add the page splits per request. This can be done. Go. So, and now, so here I see what happens. So, what the system will show me in this case is that I have a huge amount of page splits, and normally when I insert the record into the heap, there is none of them. Whoops, here it was. Here you can see what happened. The first part, the peak you see, has occurred in the GUID when I inserted the GUID. And the second one has happened when I inserted data into a heap. Well, to be honest, a heap can't have a page split. It's not possible because it's an unordered bunch of data. The second thing I would like to, so you see that with analysis you can convince your customer that you have some problems on your machine, maybe with your design or anything else. What I really like is that if you don't use the perfmon, then you can use all these metrics directly from SQL Monitor. So it means you have one tool where you can see the weights and where you can see what the perfmon counters are. In the overview, for me it's interesting to see what weights we have had in this situation. So what I'm doing here, going back, this is what I really like, and it's not a commercial, I like it. I see here the weight stats I had within the last 5 minutes. And what is the most prominent one is the write log, which means we wrote data into the database. But what I see here is that the average wait time, from my opinion, is very, very high. It's too high because this means the average wait time for every single waiting process, it took 6 milliseconds to flush the data to the log file. And this is, from my point of view, if you're running a web shop, a no-go. It's too long. So the problem here was that the customer had both files on one drive, and it was a spindle, so both were very, very slow. The second common wait type was the page-ledge exclusive, which means there are write access to the pages. And this was only in the last 5 minutes. So the first thing was that we've detected there are too much page split. They should redesign the system. And the second thing, what we have detected with that, when we saw the average wait time, we pointed to the fact that the log file, or that the data file and the log file should be on different storage. And that's what I'm doing now. Maybe you have kept in mind the values we had for the insert, but now let's look what happens when I change it, but not much. So I put my log file onto a different disk. Go, 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 Johnny, go, and hip. It's much faster. The creation is very much faster than the first one was. And there is no trick behind what I show you now. Please, there is no application running in the background or anything else. No, I'm not cheating. Yeah? So I'm a very honest one. So that's the reason why my wife had married me. So again, I create the numeric table, the GUID table, and the heap table, and I run again my store procedure. Come on, come on, come on. That's it. And now I want to check, while I'm running the process, what will be the main weight stats, the main weight types we will have while the procedure is running. The first thing I check is the numeric again. Boo, boo, numeric. I think that it was approximately 17 seconds roundabout. Was it, huh? 17, 18 seconds. So I hit it again, and now I check. Oh, come on, fast, fast, fast. And you see what happens. I don't have a write log. I only have, oh, it's finished. I have a very fast laptop. Yeah. It's like a VW with a diesel particle filter. So, see what happens. It's the same structure. The table has exactly the same structure. Look to the performance boost we have. From 17 seconds to under 6 seconds, only by replacing the log file to a dedicated storage. 6 seconds. Now let's look to the heaps. To the GUID. So once again, everything marked. Stop, stop. Okay. Yes, nothing is waiting. Go. And here you can see that forget the first one. The write log is the most prominent wait stat in that moment. And that means that the system is more working with writing data than locking data. Hey, I want to have this page. The other one came and said, no, this is my page. No, there is no lock in between. You see latches, but you don't see buffer latches. And here we are in 3 seconds. Really fast. And the last one, I see Simon laughing. It's a heap. And again, nothing. So let's check this. I run the heap, and it's only a write log. Forget about the page ledger. They're only here by accident. So it's done. 2.7. The heap was the fastest one. This was the first question I asked. What do you think? What is the fastest one? I would always, if I have the chance, prefer working with GUIDs instead of integers running integers. That was the advice I gave to the customer. And we changed it, and we changed the log file. But now, let's come to the SQL Monitor again to see how we have changed the optimization. You see that the premium weight stat isn't anymore the right log. So that means that the system also, we had the same workloads, is not dealing with writing to the log, but more with, let's say, internals, because it's grabbing for exclusive logs. But if I look to the right log here, it's the second one. Look to the wait time. From 6 to 1. It's 6 times faster. And this is something what you should take into consideration when you're dealing with your customer and watching for bottlenecks you will have in your system. And you can grab it by using only the wait stats, and yet you can compare how was it 5 minutes before, 10 minutes, 15 minutes, and so on. I think that will give you a really, really cool and a good choice to convince your customers or your managers that you would change the configuration of your SQL Server. We have 6 more minutes. Hey, I'm finished. This is the first time I'm just in time finished. So there is some place for questions. Any questions? Yes?
Sure, if I have a question, it's more like a comment.
Yes.
First of all, what you have shown us is that slow disk access is bad.
Yes.
It had nothing to do with concurrent GUIDs or anything else.
Okay.
No, it didn't.
Mm-hmm.
Yes, certain operations will lead to more writes.
Absolutely.
But what you have proven is that more writes
Mm-hmm.
on a slow disk slow everything.
Mm-hmm.
I think that any DBA knows that.
Okay.
So just replacing the disk with a low latency,
Yes.
you just resolve.
Mm-hmm.
Second thing, what I don't understand is from the SQL Monitor that shows 10, the last, the wait states. How do you separate your 3 runs with these things?
Well, that is, in this case here, not feasible, no. Then I have to run the perfmon with it, or any other DMVs, for example.
Probably a trace, because even the perfmon.
Yes, yeah.
So, this doesn't show where the waits were happening, just that they were happening.
Okay.
The only thing that proves something
Okay.
was the timing that you had.
Yes, absolutely. Yes. Okay.
And for the GUID versus
Yes.
heap,
It's
is that the distribution, and the difference, at least 4,000 rows, is, I would say...
It's 100,000 rows. Yeah.
Well,
Yeah,
100,000 rows. I don't
Yeah, I think
the
it's a
timing-
debate what we don't have to discuss here. Yes, you are right, but this is not about weights, but it's more about the structure of your
Page
tables.
versus non-page.
Well, yes, so long story short, many people do think that page split won't occur if you have contiguous running numbers. This is not the right thing. If you have a concurrent system, and that was what I wanted to show you, you have the same amount of page splits, even you have numeric values or you have GUID values, because they are concurrent, running on the same thing. Why it makes the GUID much faster than a clustered index with the contiguous is that you spread the workload over multiple pages. Yes, you're right. Perfect. Yes. Any other comment or question? Better here. Yes?
I'm probably being really stupid, but I still don't understand why the concurrent integer causes the page splits.
Why? Okay, yes. I will show it to you. I'm prepared. Because I know that might be happen. Let me see, where is it? I know. This is a different slide, but I put it into the slide before I send it to Redgate for the upload for you. This is my blog post. Come on, here it is. I have a different slide. Come on. And bing, 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 bing. Yeah, here it is. So this is the clustered index with the contiguous running value. What will happen here is that the SQL Server has a so-called hotspot because it's running every single value, 1, 2, 3, 4, and will put it at the very end of the index. With the GUID, you don't have this. With the GUID, the system will spread the value over all pages because they are random. So that means that we have here very much page splits because the GUIDs will be inserted anytime here on this page, and then we have it on the end. What will happen with the integer value is this one. When you have concurrent systems running, so that means multiple systems running, so every single process, you see it here on every CPU, we have 3 running processes, everyone will grab an identity value. And then comes the problem with the concurrency because of the locking. That means if I got the number 11, then the 7 is before me because the resource was earlier for him, so he went from the suspended to the runnable mode. I came with the 11, and after me comes the one who got the first identity value, which was the 4. And what will happen in the system? Now the inserts were 7, 11, 4. So if the page is full at that moment, the 4 comes in, and we have the page split. And this is only when we have so high concurrency in our system. That will cause the page splits in a clustered index or in an index with identity values. Is that okay? Great.
Can you counter that by, rather than using identity, using the new sequence functions?
Pardon?
You know, the new sequence function.
Yeah.
So you can pre-assign
Yeah.
the IDs. So would you be able to counter that sort of thing?
The good question. The question is, can I avoid this when I'm using the sequence instead of identity? No, because it's the same behavior in. So we have a range of values we get. So
even if you would distribute those ranges specifically between the applications?
So that means that you create your own hash values, what you put together. Maybe with partitioning, yes. But from the basics, I've demonstrated, no. It's the same. Any more question? I have 10 more minutes. Oh, that's great. Then I have more. And you can fire on me. I'm German. I can dance. Huh? Come on. So if you don't have any question, any comments, anything else, then it would be a good idea if you would like to see SQL Monitor live, go to the hands-on lab that we can check that, you can play around with it, and maybe it gave you a little bit of information about how weight stats will work, what the meaning of weight stat is, and how you can analyze weight stats. The weight stats is a guarantee for you that you can define or can find the bottlenecks on your system. What you have to do is you have to have a deep knowledge about the different weight stats, and this is something what is really a cool thing. That's one of my favorites. If you don't know what it is, let's say here the I/O completion, whatever it is, here is the explanation. That's in the tool. And if you read it, then you can see what depends on why can that occur. For me, it was a really great help when I got in touch the first time with weight stats. And if you want to see what it might be, sometimes if you want to see what query has caused this weight stat, then you may see it in the affected queries too. You can grab them and can analyze them. But that's more a developer part, not a DBA part. Yeah. It depends. Okay, yes, it's absolutely right. I see you're a perfect SQL Server engineer. It depends. Oh, what's that? Oh, a party now? I see. Yeah, I believe you really want to see me dancing. Hey, make the lights on. So, well, then I'm finished. Feel free to visit the booth, see what the SQL Server Monitor can do for you. I hope you have enjoyed my session, that you had a little bit fun the last 30, 40 minutes. Have a good time and see you maybe next year in London. Bye.